Okay, in this video I want to talk a little bit about function notation. So we're going to use the symbol f parentheses x to denote the output that corresponds to an input of x. So the thing inside the parentheses is the input. And then the symbol f parentheses x represents the output. So let's try that out with an example. So let's look at a function we've already talked about. Y is equal to 2x plus 3. And let's even go one step further and let's have an x in mind. I'm going to try plugging in x is 5. That sounds like an easy x. X is 5, then the corresponding output would be a y, which would be 2 times 5 plus 3. 10 plus 3 is 13. So the input x is 5, the output y is 13. So this symbol f parentheses x says what's the output corresponding to a particular input. So one way that I could denote this input and output is instead of an x, our input is 5. And then the symbol now says what is f doing to 5? What is f of 5? And what is f doing to 5? Well, we just calculated the output. The output is 13. Okay. Another way that we're going to see it, because y also represents our output, is whenever we see f of x, this f parentheses x, we can just think about that as meaning y. So this entire symbol put together means the same thing as y. And so that means my formula, y equals 2x plus 3. If y is the same as f of x, the output, I could also have written that as f of x is equal to 2x plus 3. So this tells me the same information as that guy. And so one way to think about this f of 5 is 13 is if you just plug in a 5 for x on both sides, that would tell you f of 5 is equal to 2 times 5 plus 3, which is 13. Okay, so I'm kind of going in circles here, and the point is just this. Like this is a combined symbol now, f parentheses x, or f parentheses number, where the number inside is the input, and this symbol is supposed to be equal to whatever the corresponding output is, whatever our rule happens to be. Okay, let's try another example. Let f of x be x squared minus 7x. And I'm going to try and find f of 3. Okay, again, keep in mind how I'm saying this, f of 3. F is a function, it's a relationship, it's how do I turn an input into an output, and we're applying it to 3, f of 3. And so that means this is my input that I stick into that formula, which theoretically should be simple. Just everywhere we see x, we stick in a 3. So let's see, 9 minus 21 would be a negative 12. So f of 3 is negative 12. Okay, one other way that I can use this is keep in mind that the input is an x, and the output is an f of x, which is also a y. And so I could also turn this into a point on the graph. So this is corresponding to a point on the graph, which is x is 3, y is negative 12 in this case. And I can also go in the reverse order. I could give you a graph and ask you to find a value of f of x. Okay, so if I give you a graph of a function, I haven't even told you what the formula is, doesn't matter. We're just looking at that and saying f of 2. The 2 inside the parentheses, that means x is 2. My input is 2. And looking at the graph, if somebody told me my x was 2, I just have to go up from 2 until I find a spot on the graph. And so it looks to me like the corresponding y would be maybe 2.1. I don't know if you can tell, but I put it a little bit bigger than 2. But whatever. It's whatever this number happens to be. So the corresponding y, which is also going to be my f of 2, again, this symbol represents the output, is going to be approximately 2.1. Okay. Let's try another one. Okay, so this represents a height formula. I'm not going to write down units or anything, but this is actually a height function in US units, so feet in seconds. But that's irrelevant. We're given a function, we're given a formula for the function. It asks us to find h of 5. All we have to do is stick in a 5 for our variable, which unlike normal where I would have f of x, it seems like instead of our function being called f, it's being called h. I'm not that scared by that. And instead of using x as my variable, I'm using t. Again, not super scared by that. A lot of times we're going to be using t for time instead of x for independent variable. So x's and t's kind of interchangeable. We're going to be using both of those a lot. So h of 5, I'm just going to stick in a 5 for my t, both on the left side and on the right side. So everywhere I see a t, I stick in a 5. And then we just plug and chug. 5 squared is 25, and 25 times 16, I believe, is 400. 100 times 5 is 500. And if you stare at that for a second, 500 minus 400 would be 100 plus 30. So our answer is 130. So find h of 5. We found h of 5. Okay, let's look at another example. Let f of x be x squared plus 3x. Find a bunch of things. I want to find f of 2. I want to find f of a. I want to find f of a plus h. And I want to find one more thing, but I'm not going to tell you what it is yet. Okay, so let's start off by finding f of 2. So f of 2 is simple. Just instead of f of x, we're sticking in 2. So keep in mind, look at this symbol compared to this symbol. F parentheses x, f parentheses particular number. That just means we're putting this particular number in where this formula has an x. So f of 2 would be 2 squared plus 3 times 2. I'm going to make sure to put all those in parentheses just so I don't forget to keep track of minus signs or something like that. And that seems to be a 4 plus 6, which is 10. Okay, so we got our answer to the first part. Second part, f of a. Well, that looks, I don't know what to think about that. I mean, it looks almost like this, only instead of an x, it has an a. So I guess my answer would be the same thing, only instead of an x, it has an a. You could also think about it as being like this f of 2, only instead of particular constant, we have unknown constant a. I don't know. But basically, we're just changing the letter of the original formula. Everywhere you saw an x, now we're sticking in a. Okay, it's not that scary. I could replace letters, it's not going to change anything. Okay, a plus h. Okay, this one I do have to be a little careful of, because looking back at the original, where the original problem had an x, I now have this a plus h. So I have to be careful, like, the tendency is going to be to put a in one spot and h in the other spot, but that's not what it says. It says we're taking a plus h and we're sticking it in for x. So we kind of want to think about our function f of x equals x squared plus 3x as meaning f of input equals input squared plus 3 times input. And so if we want to find f of a plus h, we need to stick that in all of the places, everywhere we saw an x in the original formula. Or f of a plus h is going to be a plus h squared plus 3a plus h. And keep in mind, I also need to put parentheses because I don't want to just square the h, I want to square the whole thing. So I don't want to say a plus h squared because that looks like I'm only squaring the h. I want to take the whole number and square it. So same thing as when I plug negative numbers into a formula. If I plug a sum into a formula, I also want to make sure I stick it in parentheses so I square the entire number or flip the sign of the entire number. And then finally, plus 3 times a plus h. Again, that's playing the role of the x in the original formula. So each of the x's has to be replaced with a plus h. I think I can maybe do something to simplify this, so I'm not going to leave that quite like that. Because this is a plus h squared, which is a plus h times itself. And so it looks like I can FOIL on the left, and I can distribute a 3 on the right. So a squared plus ah outside plus ah inside plus h squared last plus 3a plus 3h. So that's my FOIL of FOIL, and then I've distributed a 3. Okay, hopefully this is making some amount of sense. I don't know why I decided to simplify this, but sure, if you wanted to, you could simplify it. I guess I could also go one step further and say AH plus AH is 2 AHs. Okay, the last thing I want to try and find is a giant mess. But it's a very particular giant mess that we will see again in the future. Okay, anyway, so conveniently we've already figured that out, and we've already figured that out. So we're just going to combine some of our previous answers to figure out this new thing. Okay, so let me make some room on the board. I will condense my answer for f of a plus h. F of a plus h ended up being a squared plus 2ah plus h squared plus 3a plus 3h. Okay. So if I want to find that thing, this weird fraction, my numerator is this thing minus this thing. And again, when I plug a formula in, or when I plug something complicated into a formula, make sure I stick it in parentheses. So parentheses a squared plus 2ah plus h squared plus 3a plus 3h minus parentheses f of a was this guy, a squared plus 3a. And then all of that divided by h. Looks like fun. Okay, let's see. I can distribute a negative, and then I see an a squared and an a squared, so I can maybe combine like terms. Okay, so I see a squared plus 2ah plus h squared plus 3a plus 3h. Distributing the negative, we have minus a squared minus 3a. Okay, a squared is actually going to cancel. 3a is actually going to cancel. And let's see what we have left. 2ah plus h squared plus 3h, all divided by h. Okay. Well, I see three terms in the numerator, and all three of them have an h, and the denominator has an h, so maybe I can cancel something. So let me try and factor an h out. So I will write the numerator as h times whatever's left over. Okay, so let's see, h times something would be 2ah. So I guess it has to be h times 2a. H times something is h squared, so I guess it's an h. And h times something is 3h, which is 3. So my h's cancel, and I get as an answer 2a plus h plus 3. I am so excited that we did that, and we didn't confuse ourselves, and we got all the way to the end and simplified. Yeah, put it in a box. Okay, so let's talk for a second about why exactly this particular thing is important. This expression right here is called a difference quotient. Don't worry about that. This is not that important. It's just, I'm telling you where we're going to see this in the future. This is something that we'll see again when we get to the very beginning of calculus. So calculus is built on something called a derivative, and this is kind of one of our fundamental building blocks, one of the common things we're going to be using algebra-wise to calculate what a derivative means. And so, if we do one other step, if we pretend this h isn't here, 2a plus 3, ignore why I'm doing this, just bear with me. If you pretend h isn't there, what we just did was actually we calculated a derivative. And that isn't going to matter until we get to a calculus class, but my point is that these steps that we're doing of just simplifying things and combining fractions and canceling things, they're things that we're going to keep seeing over and over and over again for our entire mathematical career. Okay, so again, this was something called a difference quotient that's somehow related to derivatives. That's not super important to us, but it is an example of something we're going to end up doing with function notation.